This is the 10th video, the last video for the solutions to the handout using the lens equations worksheet 1. Let me read question 6 to you. A diverging lens with focal length 15 centimeters is creating an image. The object that created the image is 20 centimeters away from the lens. A reads, determine the magnification of the image. So we've got a negative value for the focal length here because we're dealing with a diverging lens, and we're also told the distance of the object. We've got our lens equation written out here, so all we have to do is rearrange it to solve for 1 over di. So we subtract do from both sides, and then it becomes then 1 over f subtract 1 over do equals 1 over di. We can flip that, of course, so we can rewrite it from right to left. 1 over f subtract 1 over do, and now let's substitute our values. So 1 over di will equal 1 over minus 15 subtract 1 over 20. 1 over di will then equal, if we convert these from fraction form to something with a decimal, it becomes negative 0.067 subtract 0.05. All right, so di will then become this, the answer to this, and then we find the inverse of it. Okay, so 1 over negative 0.117. Let's shift that up a little bit, and we get an answer. Di equals minus 8.55 centimeters. Now we haven't got the magnification just yet, so magnification is minus di over do. Plug the values in there, so minus 8.55 divided by 20, and we put that into a calculator and divide, we get an answer of 0.427. Question B asks, is the image real or virtual? Well, it's virtual because our answer here, di, is a negative value. Is it upright or inverted? Well, hi, well, let's back up a little bit. Remember that in our magnification equation, hi over ho equals minus di over do. And that means hi over ho gives us a positive 0.427. So the fact that we're getting a positive value would indicate that, assuming that the object is upright, then hi would have to be positive as well, which means it's upright too. Then the last part of question B asks, is the object larger? Sorry, is the image larger or smaller than the object? Well, you'll notice that our magnification here, that answer is less than 1. If the magnification was 1, then that would mean the image is the same size as the object, but it's less than 1. Sorry, I've written that wrong. M is less than 1. Okay, so that means that the magnification, the image is going to be smaller. Okay, if the object was smaller than the image, or the image was bigger than the object, then we would get a value of m that was greater than 1. But the fact that it's less than 1 indicates that the image is smaller.